Your software engineering exam starts in exactly 30 minutes, and you are staring down a 250-page textbook. We are going to compress that entire unit into a single structured mental framework of definitions, diagrams, and memory tricks. This chart shows the historical reality of the software crisis. These red spikes represent uncontrollable costs and severe schedule delays when development lacks a formal structure. Software engineering is the solution, a disciplined, systematic approach that replaces chaos with engineering principles. Learning these principles is about more than passing a test. It's about understanding the rules used to prevent project failures in the real world. Every engineering project follows a foundational blueprint called the Software Development Lifecycle, or SDLC. It starts at the top with requirements, which defines exactly what the software is supposed to do. Once the what is established, we move to the design phase. This is the stage where requirements are converted into a technical blueprint, defining how the software will be built. From there, the process flows through the execution phases, coding the product, testing to find defects, deployment to the users, and maintenance to keep the system running over time. By following this sequence, a team ensures they aren't just typing code, they are following a predictable manufacturing assembly line. While the steps are universal, the model you choose depends on the project. In Quadrant 1, we have the waterfall model. As this linear staircase suggests, it's designed for projects where the requirements are completely fixed. If the requirements are unclear, you move to the prototype model. Here, you build a sample first to get customer feedback, ensuring you understand the needs before building the final product. The evolutionary model delivers software in a series of working versions. Finally, for projects facing significant, unpredictable threats, we use the spiral model, which cycles through continuous risk analysis. Selecting the wrong model for your environment can lead back to the delays of the software crisis. These 4 key words, fixed, sample, versions, and risk, give you the clarity needed to choose the right path. To ensure the software is easy to maintain, we look at 2 design metrics. On the left is cohesion, which measures the relationship of elements inside a single module. For a focused system, you want high cohesion. On the right is coupling, which measures the dependency between separate modules. To keep a system flexible, you want as little dependency as possible, meaning low coupling is the goal. Combining tight internal focus with loose external connections creates a system that is easier to update without breaking the entire codebase. Before the software is released, it must be verified. Testing is the process of finding bugs, while debugging is the act of actually fixing them. This verification happens at 4 levels, starting with individual units, moving to how they work together in integration, checking the whole product in system testing, and finally reaching user acceptance. You also need to distinguish between your perspectives. Black box testing views the software from the outside without looking at the code, while white box testing requires full visibility of the internal logic. Let's do a quick system test of your own. Without looking back, name the model used for unclear requirements and the rule for cohesion. If you said prototype and high, your short-term recall is already working. To wrap up, we are going to synthesize everything into 2 memory chains. These sequences act as anchors you can use to unpack almost any question on the exam. First, memorize this sequence for the models: fixed, sample, versions, risk. These 4 words correspond to waterfall, prototype, evolutionary, and spiral. Second, memorize the process timeline: what, how, code, test, release, maintain. This covers the entire SDLC from requirements to maintenance. When you remember these 2 strings, you have a mental map of the entire unit. Every definition and comparison we've covered branches off from these 10 words. By anchoring these formulas in your mind, you've turned a stack of definitions into a reliable roadmap for your exam. You are prepped for Unit 1 and ready to move into our next challenge, project management.